The diastolic dysfunction. See, the concept of diastolic dysfunction is not as straightforward as of the systolic function. Systolic function, it's the contractility, it's the pumping function actually. Theoretically, yes, diastolic function means ability to relax, or in other words, ability to receive blood without causing an increase in pressure. Okay. What happens in diastole? Okay, this is LV, this is LA, these are pulmonary veins, which are connected to capillaries and then pulmonary artery. Okay, your lungs. So what is happening in diastole is this mitral wall is open. Okay, so LA and LV are in connection with each other. Okay, and practically they will share a pressure, means they tend to have a common pressure. When two chambers are openly connecting to each other, they tend to have a common pressure. Okay. Now what happens is, in diastole, LV is receiving blood. Okay. And its wall is getting stretched with that blood. Now, once it is getting stretched, it is producing a tension. Okay, that tension results in building up of pressure within the LV cavity, like a simple rubber. Okay, there is some pressure here, means some tension here when we are stretching it. Okay, so similarly, when you stretch the wall of the LV with blood, there is a tension, okay, which is transmitted to the cavity of the LV. So there is a building up of pressure. Okay, akin to inflating a balloon. When you inflate a balloon, what happens? You push some air into it, the volume increases, and the pressure within the cavity increases. We have discussed this in 9th class. Charles' law, Boyle's law, that what happens? That temperature remaining constant, the increase in volume will cause increase in the intracavity pressure, and decrease in volume will cause decrease in the intracavity pressure, depending upon the properties of the wall of the container. Now what God has designed myocardium in such a way